Hi guys, today we are going to see the Taylor series expansion of f of x using Taylor series and Maclaurin series. The Taylor series expansion of f of x at x is equal to a is given by f of x is equal to f of a plus x minus a f dash a plus x minus a square divided by 2 factorial, second derivative at a x minus 3 x minus a cube divided by 3 factorial, third derivative at a, and so on till x minus a raised to power n, f nth derivative of f at a divided by n factorial. Also, the Maclaurin series is defined at x is equal to 0. Now, this means we have to put a is equal to 0 in the above Taylor series. We'll get f of x is equal to f of 0 plus x f dash of 0 plus x square f double dash of 0 by 2 factorial and so on till x raised to n f n derivative at 0 divided by n factorial. Let's solve an example to know better. We need to find the Taylor series expansion of e raised to power x, okay, at x is equal to 0. Okay, so we find f of x. We first write f of x is equal to e raised to x. Take the second derivative, f dash x is same, e raised to x. Now we need to find that x is equal to 0. So put x is equal to 0, you'll get 1. Similarly, f double dash of x is equal to e raised to x. That is also equal to 1 at x is equal to 0. And so on. If you calculate this, you'll get nth derivative of x at x is equal to 0 equal to 1. So the Taylor series expansion is given by f of x is equal to f dash of 0 f of 0 plus x f dash of 0 plus x square f double dash of 0 divided by 2 factorial and so on till x raised to n divided by n factorial f n at 0. Okay, so f of 0, you know, like put f of 0, you get 1 plus x f dash of 0 is also 1 plus x square by 2 factorial plus next term will be x cube by 3 factorial plus x raised to 4 by 4 factorial and so on till infinite. So this is Taylor series expansion for e raised to x. So this can be also written as e raised to x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial and so on till infinite. In similar way, we can find sin x Taylor series also at x is equal to 0. This will come out to be x minus x cube by 3 factorial plus x raised to 5 by 5 factorial and so on till infinite. Cos x at x is equal to 0. Remember, cos is an even function, so the even terms will be there 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial, so on till infinite. Let's solve a gate problem. So this question was asked in gate e raised to x plus x square. We need to find a Taylor series at x is equal to 0. Okay, so before solving this question, just use your mind, okay? And you see, like you don't have to take on derivative. You can, if you know, like the Taylor series expansion of e raised to x is 1 plus x square by 2 factorial plus x cube by 3 factorial, so on till infinite. E raised to x square, Taylor series will be what? You replace x with x square here. You'll get 1 plus x square plus x raised to 4 by 2 factorial plus x raised to 6 by 3 factorial, so on till infinite. Okay, so Taylor series expansion of e raised to x plus x square is nothing but equal to Taylor series of e raised to x into Taylor series of e raised to x square. So this comes out to be 1 plus x square by 2 plus x cube by 3 factorial is what? 3 into 2, that's 6. So on till infinite into 1 plus x square plus x raised to 4 by 2 plus x raised to 6 by 6, so on till infinite. Solve this to get 1 plus we first write the x term, x plus x square term. So this is x square term, x square into 1 plus x square by 2 into 1. So x square we write here first, 1 plus 1 by 2. Next you write x cube term. Similarly x cube term can be found. So this is x cube into 1, so that's 1. And another x cube can be found if we multiply x square with x. So that's again 1. And again sorry this is not 1, this is 1 by 6 if you multiply x cube into 1 and plus x square into x, that will be 1. Okay, so on till infinite. So this is equal to 1 plus x square into 3 by 2 plus 7 by 6 x cube, so on till infinite. This is equal to 1 plus x plus 3 by 2 x square plus 7 by 6 x cube, so on till infinite. All terms of x will be there. Okay guys, thanks for watching. If you like the content of the videos, please consider giving it a subscribe for getting more updated content. Thank you so much.